Yeah, today we are talking about what? So thanks again to the hosts, Achal and Anam, for introducing me. I work as a solutions architect at Palo Alto Networks. I manage a product called Prisma Cloud, and I work with a host of customers to secure their cloud journey. All right. A bit more about myself, you can take a snapshot or refer my blog, CloudZone. That's where you can find me posting and tweeting about things. So that's all about me. Yes, so what do we start with? Okay, so this is our topic for the day, okay, and it's called OWASP Top 10 Security Risks. And this is a particular standard that has been developed, okay, by a group of individuals. It was an organization, and then OWASP as an entity, okay, they adopted these as standards, okay. And that is because they found out quite commonalities, quite similarities between the kind of threats, the kind of risks that were being identified in a process of CI/CD, or I would say the entire software supply chain environments, right? So what does this talk look like? Now, if you see in terms of what does the cloud environments look like? Now, if you talk about security, right, you first need to understand what is cloud security, A. Second, you need to understand what is security for CI/CD. Then, if you want to really understand these standards, right, around OWASP top 10, okay, you need to understand it like a standard, like a law, okay. Anyone studying law over here? I mean, this is a technology forum, but any law students out here? No, right? Good. So these scenarios, these standards, okay, when you need to kind of analyze them, you first need to analyze what was the breach, how it happened, and then try to map it with those corresponding standards to kind of meet and mitigate it in future, okay. So that's why we'll see three scenarios, okay, three different types of compromises and how they meet or map to these standards, okay. And in the end, obviously, we'll showcase what are these standards all about, okay. So yeah, I mean, people start with memes. I start with this slide, especially when I'm talking about security, and very important one to kind of note, okay. And on a serious note, national security should be, I mean, should encompass cyber security as well, and that's what the vision of our government is, our Prime Minister is, okay. And I mean, we should all kind of take care of that. So I mean, just taking a step back, okay, and trying to understand, okay. I mean, there were a lot of folks out here who are developers. Have a show of hands, developers, pure developers, okay. Cloud guys, infra guys. No, this is a cloud event here, come on. Okay. Very few folks, right? Now, if you had to kind of think from writing your application, from deploying your cloud environments, how many of y'all have thought about it from a security perspective? Or is it like, mera application chal raha hai na, bas, that's the thing, right? Is that something that you'll do? I see someone smiling, so I can relate and agree to that. So yes, how many of your cloud infra guys think that my environment has to be secure irrespective of the application? You think like that? Cool. But what about your application? Who is responsible for that? I don't want to put you in a spot. That's okay. Not your end user, but your entire team. I mean, it's a shared responsibility. Okay, and that's what we'll see in this slide. Okay, so if you see over here, there are, I mean, as a cloud environment or from an application development perspective, okay, if you see from a responsibility perspective, okay, whether it is on-prem, whether it's an IaaS, whether it's a SaaS, whether it's a PaaS, okay, the responsibilities differ for each of these scenarios, okay. So whether it is data classification, whether it is app level controls, okay, or physical security, it's all different and it differs for each of these, environments, I would say, okay. So whether the blue ones that you're seeing, okay, it's either the cloud customer, okay, and the gray ones that you're seeing is the cloud provider. So when I say cloud provider, it will be like a CSP, like GCP, AWS, and so on, okay. So that's where the cloud security ambit lies in terms of the line of responsibility or line of separation, okay. However, there are overlaps, okay, and that overlap is generally based on how you are designing your architecture, how you are designing your environments. All right. Now, of course, I started with a note where you want that imbibed, you want this culture around security imbibed in your national security, and what better than a very new and the latest gen of transport that is there in India, okay? And I'm just taking it as an abstract way of trying to inculcate that these are new technologies that are coming into the system, okay? Into the system of our governance, into the system of our infrastructure and so on. Why are they there? Okay, we need to be advanced, we need to be fast, and if you talk in terms of technology, if you talk in terms of cloud, what are these new things? Okay, so it is any new technology that is coming, okay, any new frameworks that are coming, infrastructure as a code. That's the most bare minimum thing that you can think about, okay, or the best possible thing when you if you kind of focus only for this particular talk for today, I would say it is heavily automation, okay, or automated CI/CD. All right. So if this is the pace with which we want to move, okay, these are the bullets that we need to be focusing on, okay, in terms of speed, in terms of innovation, and that always follows with some sort of automation. All right. Now, you all know the CI/CD process, the great infinite loop. Okay, everyone understands this a bit. Okay, now purposefully I have not mentioned any word in this slide. Okay, apart from of course the CI/CD process. Okay, why? Because at each of these points, okay, within the whole CI/CD loop, okay, there are multiple tools available in the market. It's a tool sprawl. Okay, to be honest. Okay. Now, which tool you use in your environment doesn't matter, okay? But when you consider it from a security perspective, okay, each and every tool is responsible to increase the surface of attack. So whether it is a GitHub library, a GitHub repo, okay, whether it is an open source library, whether it is something like HashiCorp Vault, whether it is an EC2 instance, or I would say a GC instance, okay, or it's a serverless function. Each and every touch point in this whole process just increases your attack surface, okay. Now, I don't want to scare you all. I mean, this is not a scare tactic kind of a talk, okay, but just try to think from that security mindset that each and every point through which your application goes through just increases that attack surface. Now, where and how, we'll see that in the coming slides. Okay. So, this is what a typical CI/CD process looks like. Okay. If you kind of unjumble, untwist that infinite loop, okay, this is what it actually looks like. Okay. There is some SCM, okay, some code management, software code management kind of a thing. Okay. What does that relate to? So, if you see on the top side, these are systems. Okay. And you correlate that to the objects that are responsible, which are using these systems. So, if it is SCM, what does it kind of use? Languages. Okay. GitHub will use, will store multiple languages, code of multiple languages, and it also uses languages for its interpretation, its integrations, and so on. Right. The second one can be CI tools, okay. You all know the fundamental differences. I'm not getting into that, where what is the difference between CI, CD, okay. But CI is helping you, to kind of integrate your code in a continuous manner, okay, which means it is helping you build that code and take it to the next stage. Now, who is responsible at this stage? The repositories by themselves, okay. Now, these repositories have certain capabilities. These capabilities are related to either the build process, the integration process, and so on, right? It can also have certain processes related to the integration of test execution, the scans, and so on. So that is where the next phase comes into picture, which is your artifact repo. What does this do? This is basically storing what was built in the previous step, which is where the CI pipeline comes into picture. Then finally, or just penultimately comes your artifact or your container repos, which actually rely on the artifacts. Now, these artifacts can be your jar files, war files, APK files, packages, container images, anything. Okay, these are the artifacts. So what I have done here is I have split your entire CI/CD into systems and objects, okay? And when we see forward in this whole talk, okay, you will see that each and every point of integration within these systems and how it becomes like an increased attack surface, you'll see in the entire talk, okay? And in the end, of course, it comes with the CD portion. There is a CD pipeline which actually deploys to the environments, the progressions happen and so on. And the glue to this entire thing is these two icons that you are seeing in between, okay? It can be automated collaborators or it can be human collaborators. And of course, there is something more, which is access tokens that you need or any third-party integrations that you need, all right? So this is, in a nutshell, the entire CI/CD process. Now, when you think from a real-life scenario, it is not this simple. The environments get multiplied n times, okay? So imagine that you just had one environment to manage or one CI/CD pipeline, one repo to manage, okay? What happens is, that is just one attack surface. But when it comes to a real life example, a production like scenario, okay, the processes multiply n number of times, so does the attack surface. So you will see that when it comes to the nature of the exploits that happen, the vulnerabilities that come into the system, okay, it just multiplies n number of times, and by the time you identify it at a later stage into the system, it's too late. It's totally late for anyone to kind of identify vulnerabilities or risks very late into the system. And that is why the entire ecosystem, the industry is kind of trying to adopt something called as a shift left principle, where you find early, you prevent early, and you kind of make your systems more and more robust, all right? So just taking a step into this, where I was speaking about that each and every layer is introducing more and more risk, okay? So let's go more deep dive, let's go more practical, okay? So if I have to, this might not work, okay. So just on the left hand side, you are seeing that there is a GitHub repo, okay? It can contain code for your IAC, which is Terraform, okay? It can contain code for your applications. In this case, I'm considering a few microservices. Now, these GitHub repos, when they kind of link to a tool called CI/CD, and in this case, I'm using Jenkins. Now, for it to communicate to Jenkins, what does it need? Some sort of access token, some webhook, okay? So you see that wherever you are seeing these key symbols, okay, it means that that is the point of interaction that can happen, and vulnerability can sneak in from there, okay? Not just from there, but that is your most vulnerable piece, because it is the identity component, okay? And identity is actually the new perimeter for security as well when it comes to cloud, because there are multiple services that are getting into the system, there are multiple actors that are coming into the system, which means that the more number of identities, the more is your risk surface as well. So if you see from Jenkins, okay, there are more artifacts that are being generated. From here, it is going to an artifact registry like JFrog. Okay, from there it is getting deployed to either an ECR, EKS, or GCP, GKE, and so on. Okay, so you see that at each and every layer, okay, the keys are being handed over. There is a handover happening between the systems, and that is where you see that identity as the new attack perimeter is getting introduced into the system. So if you see in that CI/CD workflow, okay, now you try to relate it to my previous diagram where I was coming to in terms of where the identities were getting introduced, the human collaborators, whether it's an automated collaborator, okay, these all are just increasing your point of failures. All right, and this does not mean that this is not the right way to use. It is just that you can use them and you should use them, but just try to protect them in the right way. Okay. Now I was speaking a bit around law, right? And why I like this example is that understanding and learning about security is all about learning from your history or your historical incidents. And that's how actually law works as well. You kind of take references from past examples, past any sort of incidents, and then try to kind of pass a judgment or pass a law saying that, hey, this is how it should have been, or this is how for future action, this is how it should be done. Okay, so let's understand certain past breaches, understand its anatomy, okay, and what happened with these breaches, and with that we'll derive, or it has already been derived, that what are these CI/CD standards. Okay, so the first one, I mean, all the three which I've picked are quite prominent ones. Okay, some of you might have read through this. So the first one is a GitHub compromise. Anyone knows about the PHP compromise that happened a few years ago? All right. Okay, so fantastic audience, you are not reading about security as an application developer. So one thing that you should kind of take away is that read about security concepts, okay, from an application perspective. How many of you have done PHP coding? I'm sure now, when I tell now, no one is going to raise their hands. So, okay, so there are a few PHP coders, okay. So are you all aware about any such kind of an incident that happened with PHP code? No, right? There was a recent, or a few years back, there was a force upgrade to certain versions of PHP. There were certain versions which were like totally discarded. Something of that sort happened, okay? So what exactly happened with PHP is that the PHP code base was residing on a self-hosted GitHub or a GitLab server, okay? What happened is these adversaries, okay, so when I say adversaries, I'm using a better term for them, okay, I am not using like a hacker or criminal word for them, okay, they are adversaries in the whole system, okay, so you can say adversaries or attackers, okay, and they got access to this self-hosted GitHub server. With this GitHub server, what they did, okay, was not that they wanted some access to a client's code or some data, okay. They wanted somehow to inject their version, okay, of some code, some malicious code into this existing PHP code itself. So they kind of disguised themselves as the real committers of PHP, introduced or sneaked in a code which was capable enough of doing a remote code execution. Now, if you all understand how serious this could have been, and this was, of course, okay, remote code execution is one of the serious, most serious vulnerabilities that can get introduced into any platform, okay. Why? Because this PHP piece of code is going to be deployed on thousands of websites, thousands of applications. Just imagine the volume of WordPress websites currently on internet. All use PHP. Suppose this vulnerability, okay, was sneaked in at WordPress level. Imagine the kind of surface that they had now to exploit, okay. All possible WordPress websites could have been possibly hacked, okay, and a lot were actually, okay. So what they did was, of course, they got access to several PHP websites which were running PHP, okay, and they were kind of sneaking in their code and gaining certain accesses. So over here, this is one of the ways in which adversaries take control of your source code as well, okay. The second one, okay, now we will see 3 examples and we'll break them down in the next part of the talk, okay. The Stack Overflow breach. How many of y'all survive on the basis of Stack Overflow? No, y'all are very good developers. Okay, now I see some show of hands. All right. So what happened with Stack Overflow? Okay, so this is a really an interesting case study which I kind of personally like. Okay, some of the adversaries they were trying to sneak into systems just for the sake of so they wanted access to certain data from Stack Overflow. They could not get direct access to the production environments. So they eventually figured out that on dev environment, there was an open access available. Okay, so if you see this flow, right, they access the dev tier. Okay, from there, in one of the configuration files, they found out certain secrets or passwords, I would say, that were available in plain text. Okay, so if you see the flow, right, that is how the attackers kind of thought through. Okay, and then kind of found out like what exactly or where exactly they were able to sneak into the system. Okay, so the second step was they found out certain services or secrets using some of the configuration files. Now obviously attackers being attackers, they tried to use this password directly into the production environment where at least their production was a bit safeguarded, okay. They could not access using this key, okay. So it was an unsuccessful attempt, okay. But then obviously these guys are adversaries, they would try their own mechanisms to use this information to gain further access. So one of the guys or one of the attackers, okay, they use this key to kind of navigate into their build server, okay, which was like TeamCity used in those days, okay. Now on this TeamCity they got access. Now from this TeamCity they got access to the SSH key, and from here they were able to navigate to the production environment. So just imagine your dev was insecure, okay, but using that they also navigated to your build environment. From there they kind of access the production environment. So of course these adversaries don't really sit through idle, okay. They find newer ways of attacking systems, finding vulnerable areas into your system, and you can just imagine by this scenario how large or how deep can be your attack surface, okay. So the whole idea is for you all to kind of think through various possibilities in which any CI/CD system can be compromised, okay. Now the third example, okay, is a very similar one, but here the scenario was a bit different, okay. So one of the adversaries, they forked the public repos for Travis CI, and it was a breach that was only for a few hours, okay, but it caused some massive impact to the whole Travis environments itself. So what they did is they forked one of the environments or one of the repos for Travis, okay, and what they did is they issued a PR on this fork, okay. Now this was more of a process gap in the whole, the way in which Travis was configured, okay. So the way this PR was configured is that the adversaries, the attackers, were able to push their code without a review process, which means that, okay, just like the first example of the self-hosted GitHub server, okay, at least they had a PR process, but this PR process, okay, they could have, they kind of passed their malicious code, sorry, is it audible? Yeah. They passed their malicious code by bypassing the PR process. Now, when this happened, okay, what was the outcome is that, if you see over here, the PR contains malicious commands to expose secrets. Now, they did not want Travis exactly to be compromised. They were not interested in Travis. They were interested that whichever secrets were there in Travis, they wanted access to that. Okay, which means that they were indirectly trying to attempt or breach Travis so that they get environments or they get access to the higher environments or any production workloads or any application workloads, okay, which means that this was a larger risk because Travis PR process was compromised over here. So it's basically a secret compromise, but then it was also a process gap. Now let's try to so obviously, like, what was this talk all about? Okay, I'm talking about OWASP top 10 security risk, and that too from a CI/CD perspective, and I'm talking scenarios here. Why? Because security works in this manner. Okay, especially cloud security, application security, it works in this manner. You need to understand past breaches. You need to understand scenarios so that you don't repeat them. So in security, the most important part is history should not be repeated, okay? So you don't, reinvent and, learn. I mean, you should learn from your past mistakes and don't repeat them, okay? So let's do an analysis of the GitHub compromise and see what actually is the outcomes for this, or what are the standards that they could have followed. And these standards are now the OWASP top 10 ones, okay? And if you see, there are certain guidelines to that, okay? So this scenario, which is the GitHub, it actually breached or kind of misconfigured 4 of these scenarios or 4 of these standards, okay? The first one was insufficient flow control mechanisms. So if you kind of just recollect the GitHub scenario, okay, what was happening over there? The CI/CD misconfiguration, okay, was a problem over there, correct? The second was an insecure system configuration. How can someone access a self-hosted GitHub account? The biggest breach that could be possible, right? insecure system configuration, okay. Your own system, self-hosted, it does not have any sort of authentication mechanism and you are allowing it to breach and bypass, correct? So it's an insecure system configuration. The third one is improper artifact validation, okay. So when I say artifact validation, if let's say someone allowed to kind of add certain files, should it be allowed to add? Shouldn't there be file integrity checks? Shouldn't there be basic things around checksums? Okay, so these are the fundamental things that should have been taken care of. All right, and the last one, obviously, even after all this, something that could have still saved them was ample logging and visibility, or ample logging and monitoring. Okay, even that was not present. Okay, so these are the 4 areas where if it was kind of thought through, it could have been mitigated as well. Okay, so what were the risks? So if you see, there are top 10 standards. Okay, these are the 4 that you see, from the OWASP top 10. Okay, so it was CI/CD Sec 1. Okay, so these are the name of these standards. It is insufficient flow control. 7th is system configuration. 9th is artifact validation. And the 10th one is insufficient logging and visibility. Now, as an application developer, as a cloud infra guy, DevOps guy, you might not be able to cover everything, but cover what is relevant to you and get the maximum, protection from a security perspective. Okay, let's understand the next one. Okay, the Stack Overflow one. Over here, it's also a bit of overlapping with the previous one. Okay, but here the important one is aspect 2, or the risk 2, which is inadequate IAM. Okay, what happened over there? Okay, they got access to a dev environment. Okay, which should not have been the place, which should not have been in the first place itself. So access control was very poorly managed, irrespective whether it was a programmatic or human, both, because in the dev environment they got access to the human credentials. In the CI/CD environment, they got access to the programmatic credentials. So both IAM aspect, okay, and again, I'm highlighting the fact that identity is the new perimeter when it comes to cloud. Okay, so IAM is, if it's inadequate or improperly configured, that means that is another risk area. 6th, insufficient credential hygiene. How many of y'all have passwords stored as sticky notes on your desktops? Yes, no, yes, I see some. Okay, so that will be the first point of failure that you can think of. Okay, I have seen people screen sharing with their sticky notes of passwords. So I mean, that's the best thing that an adversary needs. Okay, so that's another thing to kind of think through. Okay, any sort of credentials that you are storing. Okay, whether they are GitHub passwords, or access tokens, especially for CI/CD, okay, store it into a safe vault, okay, or a mechanism which will kind of not let it get exposed very easily. And the 7th, or I mean, I would say from this particular risk scenario, okay, standard number 7, it's again an insecure system configuration, because a self-hosted SCM, okay, whether it was a GitHub or the build process, was compromised again over here. Okay. Now, again, just a recap of the risks that were identified over here. So it is CI/CD Sec 2, which is identity, CI/CD Sec 6, which is insufficient credential hygiene, okay, and 7 is insecure system configuration, which is an overlap from the previous one. So if you see, we have almost covered, 7 or 8 out of the 10, okay, and we'll see a few more, okay. So the last one, which is Travis CI/CD exposure, okay. Here it was something which is very interesting. Now, this is one of my favorite topics, poisoned pipeline execution. Okay, what is poisoned pipeline? Okay, so just understand and try to relate that the CI/CD process that is there, okay, it's a pipeline for you. Okay, someone kind of sneaks in, okay, creates a plug into it and says that, okay, I am inserting my malicious code. Just related to the first example where a remote code execution module was inserted. Okay, that means now your pipeline is poisoned. Okay, I mean, I'm trying to give you that abstract terminology, that how exactly it is called poisoned pipeline. So it is basically the ability of the adversary to kind of inject malicious code into the CI process or the CD process in order to gain access to any forward systems. Okay, so that's poisoned pipeline executions. Then again, the other two are pretty much standard, which is insufficient credential hygiene and insufficient logging and monitoring. Okay, so again, this could have given them early warnings, early alerts, and that could have prevented these kind of breaches. All right. So again, this is more of a summary slide where talking about Sec 4, 6, and 10. Okay. Now, if you see, these are the top 10 standards which I have been talking about. Okay, and this is like the key slide which actually sums up the whole talk. Okay, which is the top 10 CI/CD security standards. And if you kind of still analyze, so these are only the top 3 breaches which I have, just in the interest of time. Okay, the top 3 breaches that cover a lot of these risks. Okay, but if you see, there was Sec 8, which is ungoverned usage of third-party services, or probably an insufficient PBAC. Okay, it's still related to somewhat around IAM only. Okay, so I've just skipped that for now. But just from a conceptual perspective, these 3 scenarios, if you understand, okay, they cover a lot of these risks. And when you kind of design your applications, design your CI/CD pipelines, okay, this is what something that you should take care. And even as these standards get adopted, as these standards progress into the industry, they will become standards, and even from an audit perspective, you might have to meet these standards from an environment perspective. So while designing, this is something that you should be taking care of. Okay, so what is in it from a GCP perspective? So just a summary slide again. From a GCP perspective, if you see at all layers, okay, security is introduced. So one of the platforms where security is there by design. Okay, and it is like working on several principles around least privileges. There is governance, risk, compliance modules available within the platform itself. So, and what we are talking about, okay, is only one particular area out of this, which is application security or the software supply chain security, which is where the next slide comes. So if you see, this is the CI/CD process on GCP. And now you try to understand that where are the point of failures, how you can make it more secured, whether it is a authorized container image, whether it's an IAM permission, it should not have overly permissive accesses, and so on. So these are the scenarios that you should be thinking about when designing applications, when designing your CI/CD pipelines and your infrastructure as well. Okay. And if you need more information about the scenarios which I talked about, the further reading about those scenarios, or the OWASP top 10 standards, this is your takeaway slide. Scan this QR code. It will lead to a link which kind of has a lot of bookmarks or a lot of links for reading and watching, probably consuming in your reading time. Okay, so please go through this. You can learn a lot more about security, and this is more like a living blog where I keep on updating as and when I find certain new insights around the CI/CD aspects from a security perspective. So that's all. I think I have almost ended my time. So that's me. Thank you so much, everyone, for listening. You can connect with me on LinkedIn at Dharmesh Vaya, or Twitter at DRVAYA. I'm one of the organizers for GDG Cloud Mumbai as well. And that's my blog. I work as at Palo Alto Networks, and Prisma Cloud is also another product around solving a lot of security challenges across these cloud platforms as well. So thank you so much, everyone. That's all for me.